So good morning, good evening to everyone. We've got a few Australians with us, so we'll work through those in the first instance. And I'll just start with an apology from Steve Bentley, who was going to join us, but as Tim was just saying, we have an issue with the issue. The good news, the news was good in the last Drake's Lounge Australia, that the dish was working up at Heathcote, the dish that's behind Tim's head. Yeah, that one. And it was working well, but then Steve tried to contact the dish remotely from his home and couldn't do it. So he's on his way up there today to have a look at the dish and the electronics, associated electronics. I'll just read his email. No, that's the wrong email. Here we are. I'll be an apology. Attempted to operate the dish remotely, appears to have failed. Based on an assessment between Tim and myself, our conclusion is that the receiver LNA module may have failed. The other part of the dish is its system is up on the dish. The front end is in a separate box. It appears to be delivering an output at 70 meg, but much lower RF than expected. And normally a noise floor of -80, this has dropped to -95, consistent with the LNA failing. So Steve's speculating what might have happened: cable damage, semiconductor failure due to lightning, damage due to water ingress. So it's a sealed box, but it does have a Gore vent, and the humidity can build up inside the box. So he's going up today to have a look. And Tim, have you got any more background on that to add to that?
No, not really. So we did have connection up to the dish remotely, but we just weren't getting a good signal, and it looked like it was something's failed in the low noise amplifier. So Steve and I had a bit of a chat about this, and we don't know what the problem is, but if it's just a bad connection, then that's much easier to fix. The worst case is there's been some sort of static discharge and it's blown up maybe one of the input transistors or something. But we don't really know at this stage. So Steve's going up today to have a look. But I don't think he'll be able to do that much. We'll have another visit in a couple of weeks' time, because the problem is you've got the low noise amplifiers right at the end of the dish. In fact, if you see the little picture in the background here, it's up at this point. So you have to lower the dish and put up a scaffold and then climb up to it to get to that, and then pull it apart and have a look. Excuse me, I have a cold. So yeah, it'll be a little while before we get this running, which is unfortunate. But I have some. Steve did some. He did a number of tests looking at the small Magellanic cloud, and he got some results, which I think he sent you, Paul. I don't think he's quite analysed all the data properly. There's some issues that need to be sorted out. I collected some data of the small Magellanic cloud back in August, which I'll show you, which actually produced some really nice results. So I can show you those when we get to that.
I've got the document that Steve sent to me, which I can share, but I'm not really sure what I'm looking at. So Tim, you might be able to explain a bit more clearly.
Yeah, I can talk you through it if you want to show it. Yeah.
Yeah. So I'll share this screen, which is this one. So we're getting the graphs.
Yeah. So okay. So this is Steve was looking at the this was some experiments he did some time ago where he was looking at the receiver gain as a function of the temperature. And so the idea was to try and keep the temperature of the system constant, which is why there's a Peltier cooler up there for the low noise amplifier. And possibly the next stage gain system. I'm not entirely sure.
Yes,
So what he
that's-
was interested in was just basically
yeah,
where he was trying to calibrate the gain as a function of temperature. So it does
yeah.
vary a little bit, but not a huge amount.
Looks
So,
like
so
it's
that's the
up to
electronics.
about 17, pretty stable up to 17, according to that.
Yeah.
Um,
Yeah.
and then, so what was the first one? The first one was
So this is the low noise
hydrogen receiver.
amplifier. This is the very
Yeah,
first unit. And then just after that, there's another amplifier, which there's a number of amplifiers, and then there's a down converter that converts it to 70
right.
megahertz transmission from the dish down to the main lab room.
So it looks like beyond 20 degrees, we start to get negative. I don't know what the reference is. Yeah. So then this is power supply. I think we saw these last time, some of these.
Yeah, so this
Um,
is just showing how the power supply is turning the Peltier cooler on and off, and it's got a measure of the cabinet temperature. When it gets too low, it basically can't it doesn't warm it, it just cools it. So if the temperature outside gets too low, then it just starts to drift.
yeah.
But if you look at the low noise amplifier, so the cabinet isn't cooled, so you can see the cabinet temperatures varying a bit.
Cabinets
And
moving
so,
around here.
yep, so then the next one down, the low noise amplifier environment.
This one, very stable.
Yeah, you can see that's quite stable. There's the temperature, which is the red line, and then the fan speed, which is
Yep.
cooling the Peltier. It's blowing air onto the heat sinks of the Peltier cooler. And then the bottom one is there's some looks like I'm not quite sure why he's highlighting that. I think that was just the what was the cabinet temperature was
The worst case temperature swing. Yeah.
dropping. Yeah.
And that of course is in winter. Who knows what's going to happen when we hit summer?
Oh, well, that's exactly right. What'll happen is if it gets too warm, the Peltiers will be overloaded and the whole system will warm up a bit, but we're not quite sure exactly what that'll do. So we've been monitoring this. This is the thing is,
Yeah.
well, in particular, Steve has. He's been very keen to see how all this is varying.
That's just
So
an
I think in
idea.
this one, it just shows where the temperature dropped below
Oh yes,
5
here.
degrees, and so the system turns itself
That was
off, but it
September.
just
Yeah.
stays cold because there's nothing to warm it.
Yeah.
I did say to Steve that he can run Peltiers backwards, um, but I don't think he was listening to me when he was designing it at the time. It's not. Honestly, I don't think it's a big deal at this stage. I think we've got other issues that
Yeah.
are more important.
So now we're up to October. So we're getting some variation because we're going into slightly warmer conditions, I guess. And then, so you might want to talk us through that one, Tim.
Okay, so this is Steve. Steve, he was wanting to look at how consistent the system is in measuring, picking up radio signals. I personally think this is premature because we hadn't properly calibrated the whole system. So,
Yeah.
but anyway, he was quite keen to do this, so he did it. And so this is looking at the small Magellanic Cloud. And the way, so I wrote this software, and what it does is you set up a sampling grid, and then you tell the system, you tell it how long you want to stay at each grid point, and hit the button, and then it moves the telescope to that point, integrates the signal, and then saves the data to a file, and then moves to the next point. So the grid, the sampling point, you can see against a the star chart on the left. It's that, yeah, that one in green. Starts at the bottom left in this case, which is, it's a slightly bigger blob, and then goes up and then across and does this serpentine pattern across the sky. The idea was the altitude control of the telescope's much slower than the azimuth. So the idea was to step in azimuth and then just increment in altitude. So it tries to sort of follow it. And the line, you can see there's a faint yellow line, dashed line on the left, far left of the screen. That's the horizon. So you can see it sort of following the horizon. Yeah. So if you look at the way this thing works is we have a software-defined radio that outputs a stream of IQ data. So that's phase and 90 degrees out of phase data from 70 megahertz. And what the system does is it collects that data, and when it fills up a buffer, excuse me, of about 1024, it does a Fourier transform and then calculates the power. So takes the mod square of that and then puts that into another array and then averages that over a whole lot of samples. So as you're integrating, it keeps averaging that. And so the graph that you're seeing on the top right is essentially the Fourier transform, which gives you effectively Doppler shift of the signal that you're looking at. So the peak in the middle is a hydrogen line. That's in the middle of the graph. And then the double peak to the left is actually the small Magellanic Cloud. So there are components of it. Because the whole cloud's actually moving away from us relative to us. So we're probably moving away from it. And then within the cloud itself, part of it's moving further away from the center of the cloud than another part, which is moving in the other direction. I'll talk a little bit more about this later. So that's essentially the data. The gain values aren't very well calibrated, partly because, or mainly because with the software-defined radio, I couldn't find any information as to how to convert analog to digital converter units, because the thing's outputting digital data, how to convert that into a volt setting or an equivalent power setting. There was no information at all, so I had to guess at what was happening there. So one thing that Steve found was that in some of these measurements, the altitude was fairly low, and so he was picking up ground noise. So he's got a little graph. He's just showing here that the altitude in this case was 37 degrees, so it was away from the ground. And he probably has some graphs a bit later showing what those are. So yeah, that's not telling us much, that one. So this is just, I think, showing part of the scan. Excuse me. So once you've collected data, there's an analysis tool, which I've been working on. And in that, you essentially get, it reproduces the screen where you have the star chart on the left. You get the Fourier spectrum on the top middle. And then from that, you can then also create an image. So it takes all the data points and converts it into an image. And you can select a particular Doppler shift to grab the image. So the problem that Steve's done here is he selected, you can see in the graph at the top, there's this blue shaded region. So that is used to select a band over which you want to plot data. So it only plots that data. I think in this case, Steve's chosen too wide a band, and so he's getting too much background. There's another issue as well, is that the background signal, so it's that sort of flat line that all these peaks sit above, that does shift up and down a little bit depending on where you're pointing the telescope. And so what I would like to do with the analysis is actually measure the peaks the relative peak heights above that line rather than the absolute values. So I think that will improve data at some stage, but I haven't done that yet. Anyway, so this then gives a plot of a part of the Small Magellanic Cloud. And he's done it with, he noticed that as he was sampling that there were some odd samples. One thing I have noticed with our system is from time to time, the gain measurement gets a very strange value, and that gives you a really bad data point, which can skew the plotting. I'm not quite sure why we get a bad gain value. That's something that we need to investigate. So that's why he's talking about anomalous samples removed. There are a few odd samples.
Yep.
So basically, he's just looking at different parts of this and plotting it. As again, I think he's chosen too wide a band to plot. I don't think the data is all that useful. I'll show you some analysis that I've done a bit later.
Yep.
But here he's just looking at the central hydrogen line. And then occasionally he sees anomalous spikes, which
Yeah.
we don't know what those is causing those.
Just different ones that Steve's collected, I think, along the way.
Yeah.
If he's around next time, we might get him to explain further.
Yeah.
All right. So gotta work out how to stop the share. That one.
So what I'll do is I'll show you the results that I got back in August, which actually turned out really well. So if I can just show this one. Okay, share that one. Where is it? Damn it. There we are. That's what I want. That one. So can everyone see that?
Yep, we got that.
So this was I've sort of made a little PowerPoint. So yeah, essentially a little presentation. Basically, it's the same sort of information. So this was looking at the Small Magellanic Cloud, and you can see on the star chart to the left, there's the large cloud and the small cloud. There's a little red dot on the small cloud, so it's just this region here. Again, you can see just the background hydrogen signal, which is that peak. So just looking a bit closer, this is the scan that I did around the Small Magellanic Cloud. And as we saw with Steve's data, you get the background hydrogen peak roughly with very little Doppler shift, and then you get this double peak corresponding to the Small Magellanic Cloud. So this is what Steve really should have done. He should have put a very small band just on parts of the cloud, and then you see little bits of which parts of the cloud are actually moving away. So if you plot an image of that, you get a bright point, as you can see here. It doesn't look much, but if I go on to the other side, you can see that the image then shifts. So you can actually plot out spatially parts of the cloud and how it's moving. So I can just go backwards and forwards a couple of times, and you can see that that's moving away and that's moving forward relative to the center of mass of the thing. So if I then put a broader band over both of it, you can get this average. It looks a bit of a blob, but what I then compared it with, this is data that came from the Square Kilometre Array Pathfinder project, which is the large radio telescope array that's in Western Australia. And they also looked at the Small Magellanic Cloud. This was published back in 2019. And you can see on there, you can see they've got their radio image showing the cloud. And then on the right, there is actually a Doppler shift image. And you can see that just like we had in our data, with the red bit, that's moving away and the blue part is moving towards us, relatively speaking. And so that's consistent with what we're able to measure. So that was very nice. The other thing is if you actually blur out their image, you get something that's very similar to what ours looks like. So that was actually very, very pleasing. So I think the system's working pretty well, apart from the fact that we're still finding little glitches here and there. But it's still a work in progress. So that's really all I wanted to show on this punt. Uh-oh, I've lost my cursor. Stop sharing. There we go.
Very good. Thank you, Tim. Do you have any more to
No, that's all.
contribute? No.
Adrian says the central spike looks suspiciously like the SDR DC offset instead of the base frequency. It does look, but it's actually shifted off the 70 mega. It actually wasn't at the 0 line. It was shifted. But yeah, you're right. You do get that from time to time. I actually haven't seen it with the one up at Heathcote. I've been setting up a little toy system here in my backyard, and I get that a lot, that DC offset. It's a pain. But with the one up at Heathcote, I haven't really noticed it so much. And it's not exactly at 70 megahertz, that peak. It was actually shifted. So I don't think it was the background.
Yeah. Very good. Any questions from any around the room while Tim has the chair? No, all fine.
What
So
SDR are you using?
Sorry?
What SDR?
It's a SDR Play.
Sorry, I meant the hardware.
Yeah, I'm trying to think of which model. It's the top end model. RSPDX, I think it is.
Thanks.
Yeah, it's quite a nice unit.
Yeah, I've got a couple of those on the shelf here. All right, thank you, Tim. That's a good explanation of where we're up to. So we were doing quite nicely until suddenly we weren't. But we'll know a little bit more about that up to today. And so Steve will give us a report, and come the November meeting, we should be able to either we'll be back on track or we'll know what we need to do. Moving around on my screen, Roger Heap is the next person. Roger, do you have anything for us?
No, not particularly. Same as last month, I've been pretty busy. At least I got my video back this month, so you can see me, hopefully.
Yes. Yes, we are all there, and we can see you as well.
Yeah, no, I've sort of, as I say, I've been quite busy. Even on the observational side, I haven't been able to get to Wirrina for months. They were there last month, and I had a fire brigade training, which is a bit important around here at the moment. Fire season's about to start. All sorts of excuses. My wife's 60th birthday, that's took a lot of time out. Anyway, I will get back to it it's probably going to be a couple of months. Our building project's about to start again. But anyway, sometime next year, I'll get it all together, hopefully. So, yeah, not much from here. And good to see Michael. How are you, Michael? Good to see you. I've seen you for a while.
I'm well, thank you. I'm well.
Yeah.
I just don't make it to Wirrina at all because it's an extra couple of hours drive. It's a bit of a killer. And of course, we had major flooding where we are. The roads were blocked and stuff. So no, to get out there is going to be a tough one. But are you talking about still resurrecting that radio telescope at Wirrina, right?
Yeah, well, I believe so. Personally, I'm sort of interested a lot in the smaller stuff that we can spread around a bit. That sort of always has been my dream, I suppose, is to do more of the interferometry type of thing, get all of us who are spread around the country, because we've got you up north, we've got people here down south, get them all to work together and try and get something with smaller dishes spread out has always been my intention. But certainly the one at Wirrina, it's got a lot of problems, though. It does have a lot of problems, but it's resurrectable. But I really think if we could, just work on our own smaller systems and then apply it to that one would probably be a better way of doing it at the moment.
Yeah.
Because, we are all getting pretty scattered.
Yeah. All right. Good to see you.
Yeah. Anyway, we'll catch up again. So, sorry, no more to report from me at the moment, but I will get back to it sometime.
Okay, thank you, Roger. We look forward to the certainly the fire brigade training is important, as you say. We're heading into what could be a bit a disastrous summer, so keep that one up. And Michael, you're next on my screen. Welcome back. We haven't seen you for a while. Do you have anything that you want to report from what you're doing?
Well, as I'll just remind you, we moved to Gloucester 18 months ago. There's still some unpacked boxes, but I haven't. I've got too many hobbies, but I literally broke ground to put in a pier for optical astrophotography, and that was this week. So I'm already getting finding out how to put like a cubic meter of concrete in the ground. I've got to dig through clay and stuff, which is tough. But and build the shed around it and the whole thing. But I'm just wondering where I can put a baby toy experimental radio telescope, and whether. So I have a technical question. Can I, if my shed is going to be like a metal garden shed, do I have to have my dish a long way from that? Is it going to interfere, or is it, as long as it's behind the dish, it's probably fine, is what I feel would be the case. Is that right? Or do I have to put it out in an open field?
Any thoughts? Anyone?
This is Rich. The problem you've got is one is you do need the backside away from the shed. You're going to get reflections off a metal shed.
Yep.
And that's the problem with that. So the farther away, the better, obviously. And so you just and then when you put it up, or even you lean it over, depends on how you angle it. If you're going to do a drift scan, you could do north south. You could probably put it so that it's, looking south and in front or back of the shed, so that you're not seeing it, or you only see the reflections. You just have to look at that and check out the environment. You may need to. I would recommend put it as mobile as you can, and then try it in certain locations, and then move it if it looks like there's too much RFI coming in.
Or I could build my shed out of something non-ferrous, right? Non-metallic. And that would, but inside there's going to be, a metal pier and stuff.
Power supplies, you got motors, you got, something will get you eventually, I guess. So, but that'd be less. I mean, that'd be less chance of reflections and stuff. But, yeah, I wouldn't worry too much about it. We got guys that, the scope in the box. We have guys that put it out on their porch, and they're able to see the Milky Way. So if you don't make it too permanent, and you can move it around, but I would say you just go for it and worry about the RFI if you get it.
Yeah, at least I'm going to get some data and enjoy my first, like, dipping the line in the water, right?
Yeah, that's right.
Rather than wait to get the perfect system, and that gets commissioned in 5 years' time.
That's right. And I'll show you my equivalent of that. I've got a 3-meter dish in my backyard that RFI is all over it, but I'm still getting a good picture.
Okay.
But
all right,
we'll do that at the end.
Yeah. Well, anyway, the summary is I'm still just learning, and even though I'm retired, I'm running out of time for everything.
Have you taken any measurements now, like before you put the shed up, to see if you have any? That's my only suggestion, is do that, so you have a baseline for.
Good idea. Yes, and then compare to being near a metal shed. I've got a metal wood shed, so I could move the whole apparatus right next to that and see what happens, right? After I measure from being out in the field. I mean, I do have a couple of 100 square meters spare to stick a radio telescope in, but it's just a bit ugly. My wife's very much against. She's into aesthetics. All right. Thank you very much, people, and good to see you all again.
You might need to paint it a different color, Michael.
green, so it blends with the lawn.
Yeah, yeah, let it blend in. She won't even know it's there.
Yeah.
Okay, thank you, Michael. Good to see you back. And I think Duncan's iPhone is sitting there. Duncan, I presume that's Duncan Wilson.
Yeah, it's Duncan Campbell Wilson.
All yours. Have you got anything to tell us?
Did you get some sound?
Yes.
We're fine. Yep.
Yeah, I've been in a struggle with radio frequency interference, I think, for the last month. So I'm still getting data on the Vela Pulsar. It's knocking the residuals in the timing of the pulse arrivals, which is a bit annoying. And I've been working on other small projects. I have gone through my system, LNA part of the system, fairly well, and it's still in good nick. I was measuring about 25 Kelvin temperature from the LNA backwards through the system. So the LNAs are still alive and well, but there's a lot of radio interference between 800 and 900, mostly cellular phones. So it's a difficult area to work in. That's about it.
Sounds like a work in progress. Work to be done, Duncan, I think.
Duncan,
I think
something that one of our engineers built a pulsar simulator that allows us to sit there and sweep across the thing, and it looks like a pulsar to the pulsar receiver system, just because you got a limited bandwidth, and then you sweep across that, and it looks like a set pulse and a set pulse width. You might try that just to tune up your system without actually hooking to the antenna. You can just hook it directly to the input of the receiver and just use a function generator sweeps.
Yeah, I already do that. That's because I have to. Well, I'll explain a bit more. The thing I didn't say, what I'd also been doing was, as my antenna has two polarizations,
right?
I've been looking at experimenting with cross correlation in real time. So taking Lime SDR output, two outputs, one from each, and then doing a complex multiply after I Fourier transformed the two channels. And to test that, I used a carrier which was modulated at 11.1 something, 8217 hertz, which is the Vela pulse frequency. And I can see that very easily through my system. That I think it was, I can't actually tell you what the level was, but it was fairly low. So it's a single carrier, and I was sort of around about the minus 90 dBm radiated level into a test antenna, and I could see that leaking into the side lobes of the 2 meter dish. So yeah, I have done that. I think the better thing I should do is actually have a modulated noise source that is band limited for the band I'm working in, and then I can switch that up and down, which actually emulates the pulsar much better because it's basically a broadband noise source. What do you think?
Yeah, we had we had the selectable frequency, pulse width, and we had the ability to plug in more attenuation, so we can drive the signal down, the function generator signal down to what we might be expecting from the pulsar itself. I mean, really minus, I think ours is minus 50 or 60 dBm. And then, and actually get it below the noise level, and just like a normal pulsar is. So, Yeah. Also, we use GNU radio to combine the signals, the two polarizations.
Yeah.
With our two inputs, and we used a 2-channel. Get the name of the 2-channel receiver we used, but it brought it both in. GNU radio handled both of them simultaneously on a single USB-C input, and then it combined the signals for us, and then produced a .fill file after an FFT. So, yeah, looks like you're going to get it well. So, yeah, RFI. I'll show you my RFI. I've got significant RFI problems here too with just the hydrogen. So,
yeah. And the other thing I've done is, at the moment, I'm just about to move from using Raspberry Pis into using small form factor i7 computer to do the signal acquisition. There's a number of reasons. One of them, I've been running Pis for about 4 or 5 years to do this, but the second-hand small form factor computers, it's all in one box. It's nicely boxed, and it costs about the same amount in power and almost the same amount of in money to put a Pi together with the power supply, etc., and box it. So I'm moving towards having a look at that, because these Lime SDRs actually can go up to a 56 megahertz bandwidth. So I decided to do something else. I need that sort of throughput capability. Anyway.
Yeah, we ended up buying a 30-core computer, and with a USB-C connection, because the standard USB was not enough for bandwidth. So I don't understand how you're going to. The Raspberry Pi just doesn't have enough oomph to collect all that bandwidth. So we just bought a multi-core computer to collect it all, and then to run the post processing on it.
So, yeah, so I do a little bit more than just drop in the GNU radio. I do a little bit more than just drop the IMQ data out. I do the Fourier transform normally, and then it's all in vector format, and then I do a power detection, and then I integrate for about 20 cycles. So the frame rate for the fast Fourier transforms, which what I put into the final software, it's down to about 3,125 frames a second, which is enough to get a few points on the Vela Pulsar pulse, which is quite narrow, but you at least get 4 or 5 points on it. So you've got an idea of what the shape is, and you can do the timing measurement. And then that's exported as short integers into a file, and that's post-processed and ends up coming out of PDMP, which is part of the Vela, part of the Pulsar software. Anyway, that's the sort of that's the way of doing it. So I end up with about, for an hour's observation, because I do a drift scan, end up with just short of 3 gigs of data.
Yeah, that's about right. Yeah.
Yeah. Anyway, that's about it for me.
Thanks.
Okay, thank you very much. Rich, I think that's it from the Australian end. We're a bit light on this week. So if you want to move around your people at your end, and let's hear from them.
Okay. Thanks, Paul, and everybody. Let's see, Dan.
Yes.
So we already get you? Yeah, there we go.
No, but, I really don't have anything new to report. I've been upgrading the technology in my home network system, and listening into the other members here on this link. I'm going to have some issues too when it comes to setting up the scope in the box. I've ordered the majority of the parts. They're still in shipping. They're in transit right now, but I have a home security system that runs off a 2.4 gig Wi-Fi signal, and I have a metal shed in the backyard, and I'm going to have a lot of obstructions. So that's a bridge that I need to cross later on. I'll figure it out, but that's what I'll be met with. But other than that, I have nothing more to report, and I just listen in to gain the knowledge.
Great, thanks. Yeah, you don't know until you actually try to receive it whether you got all sorts of problems or not. So just go for it and then worry about it later. Don Latham.
Hi. Am I coming through? Yeah.
Yes.
Okay, hang on 1 second. Come on. There we are. I really have not got much new. I did get one of the little Explorer dishes. You can see my 16-footer back there. So I'm going from the sublime to the ridiculous just to see what can be done with the little Explorer. And hanging out on AliExpress to get alt-azimuth mounts. And there are some that are relatively cheap. And it will demand some kind of controller, which I think I know where I can get one, Rich. Some controller electronics and software that should be able to hook up to a small thing like that without any problem at all. So may be in touch with you. But that's about where I am at this point. Winter's coming on, as you can probably tell from my voice. I'm kind of with you, Tim. So that's good from Montana.
Okay. Thanks, Don.
Oh, don't forget about the shed. Any shed is a big hot lump. Don't forget that.
Okay, Wendy.
Well, not really, except I do have something that's a bit off the wall if I can beg for tolerance. I was looking through a bunch of old magazines trying to see what I could throw away, and I found an article written by a researcher who, maybe I should look this up, who was familiar with Frank Drake about an author named James Gunn, who should be in his mid to late 90s, but in the 60s, he was writing about SETI. He wrote a book called A Listener. And he was talking about we look as receivers, we look in a narrow bandwidth to look for SETI signals. And he said that we were making the mistake of looking, when we look out in the universe, we should be looking at a broader band of signals. And began to talk about how SETI races would blast these huge signals like fast radio bursts to talk about the death of their civilization. So I was just wondering if anybody knew anything about this. I guess my feelings about SETI are pretty well known. I feel like if the aliens come here, they will probably suck all of the metals out of our bodies and then turn the rest of the earth into farmland. But I just wondered if anybody had heard of James Gunn. And if I can get permission, I'll try to see if I can find a better copy of the article. And that's all for now.
Yeah, put a link to it if you want. That'd be great.
I remember James Gunn. That'll tell you how old I am. He was a good sci-fi writer of the so-called golden age, 50s, and reasonably good.
All right.
But consider how much energy is involved. If you're going to send out a signal, the broader the bandwidth, the more energy you're going to require to have a decent amplitude for the signal at the other end. So there's got to be a balance in there somewhere.
Yeah, that's what he said, that broadcasting uses lots and lots of power. So I was reading this, last night as I was falling asleep. I'm sure that if we look at the actual little article the guy wrote, I'm sure he'll do a better job of explaining it than I have.
Okay. All right. Thanks, Wendy. Michael, did we get you already? Samursky?
Yes, you did.
Okay. Thank you. And Tim Davis?
Yep. So I spoke about the
Right.
ASV
Okay.
thing, but
Yeah,
just
we've
I have a
left it,
question. So I've got a 1.8 meter dish, which I acquired, and I've been setting this up in my back garden. Unfortunately, I'm in a suburb, so there's houses and trees and things around. But I was just wondering, what sort of feed would you guys recommend for that?
I've got a Cantenna,
Yeah.
and that works fine. I've got a 3-meter dish in my backyard in the middle of Colorado Springs, Colorado, and it works just fine. But it's a Cantenna that, and a lot of these guys have between a Cantenna, a small, I guess, version of a circular feed. So I've seen the two of them, both work.
Uh,
So I guess the idea is you want some sort of resonator at the end, just to sort of boost the signal a bit. Is that the idea?
Cantenna is good because you can probably get the equivalent of, am I coming through? You can
Yeah.
probably get the equivalent of 6-inch stovepipe, galvanized stovepipe, cheap. And
Oh, okay.
that's so close to the optimum. Am I still coming through?
Yeah, go
Am I
ahead,
still
Don.
coming through?
Go ahead, Don.
So close to the optimum diameter, and so close to the optimum diameter, and it's very easy. It says my internet connection is unstable, so I'll leave it at that. There's plenty of designs around for Cantenna.
Is the length of the Cantenna important?
It's supposed to be at least probably one waveguide wavelength or so. It needs to be long enough to get a TE11 mode going
Right.
in it,
Okay.
and the probe has to be about a quarter wavelength from the back, and that's about all there is. You can get the stovepipe is nice. Stovepipe is nice because you can get a nice back for it that you can just fasten on with a few screws. And Bob's your uncle, as they say.
Yeah. Okay, that sounds good. Thanks, guys.
Thanks, Don. And you're coming through okay. Johnny Cox.
Hey, everybody. I don't have anything prepared to speak about other than I can describe kind of what I do. I live in upstate South Carolina, which is about 2 hours from Atlanta and about an hour and a half from Charlotte, close to Clemson. If you know where Clemson University is, I live. Everybody goes by my house on the way to Clemson when they have home football games. I have out in my backyard, I have a terminated folded dipole square array. And I'm monitor pretty much 24/7. Had a lot of fun. Jupiter's beginning to show itself, and I really get a kick out of. I'm retired, so I can do this sort of thing. I can sit up early in the morning and watch Jupiter go by in real time, which is a fun thing. And I use the Radio Jupiter Pro that's written by Jim Sky to kind of tell me when to look. So if I miss it, then I can use that to tell where to go back and find if there's anything there. I think I have the same RFI stuff everybody else does. Overload in the afternoon. It's worse at different times of the year than now. It's kind of pretty bad, but they're still, middle of the night and morning hours work out pretty good. And did I say I work with Radio Joe? I did say that. I hope I should have said that at the beginning. But that's what I know. Have a good time doing it. And I try to put out what data I got, and put it out so everybody can see it and compare. And that's been sort of fun. There are several others that do the same thing I do. On the .io group is what we use. But that's all I got. Thank you.
Thanks. Can you put a link to the .io group for Radio Jupiter guys?
I sure can.
All right, thank you. Dennis Hoofnagle. Can't hear you.
No sound.
Says your mute's off, but it just can't hear you.
Maybe that's better. Is that working better?
Yeah, we can hear you now.
Okay, thank you. For some reason, this machine changes the source, goofs me up every once in a while. Anyway, one of our southern cohorts here, he mentioned having too many hobbies, and that's me for sure. And I was just going to say, they're having a conference. AAVSO is having a conference in Portland, Oregon, in a week, and I see the first lecturer. They in their little synopsis of what he's going to talk about, they're talking about the fact that people are doing radio astronomy and getting good results and good information. So it might be good to somehow pick up on that and see if what AAVSO is promoting there, because I think they're all learning that Sarah model is pretty productive. Otherwise, I have nothing to offer right now. Thanks, Rich.
Thank you. Adrian.
Yeah. Hi. Well, let's see. Still struggling along, trying to get things moving. One of the things I'm sort of working on is trying to, let me see if I can get this on here. Is that coming through?
Yes.
So one of my main projects is trying to repurpose that DVRO 8-foot dish for radio astronomy. And so as you can see, I've got it out in the corner of my backyard there. So try to get it as far away from the house and whatnot. And so that's kind of like a general goal, to try to change out that TVRO feed and replace that most likely with a antenna and utilize that for RA. So that's kind of the number one goal. Like everyone else here, I'm also spread out with too many hobbies. Boy, yeah, RFI. Oh, that's a big problem for me. I'm in San Diego, California, and about a couple of miles away from the Miramar Air Base. And that is a huge generator of all sorts of RFI. The flight pattern for a lot of the fighter jets out of there go right through the beam of that antenna. It's kind of pointing sort of south right there. And they just fly right through the beam of it. And back in the old days when that was being used for TVRO, boy, it would just completely obliterate the SAT signal whenever they would get anywhere near to the beam width of that dish. But in any case, that's kind of the short-term plan, and hopefully long-term use for this dish. But so that's pretty much it. Oh, I had a comment to make about the what Wendy was talking about, the search for extraterrestrial intelligence. Yeah, I'm also old enough to remember James Gunn, and he had some great science fiction stories. I think what he's referring to, and I think Don was sort of maybe kind of addressing some of that, is not necessarily the bandwidth of the signal itself. I think everyone agrees that in order to get any kind of long range interstellar communication, you definitely need to have a narrow bandwidth. Gosh, people looking at, for example, the SETI telescope up in up in Hat Creek, California, the SETI organization, and they have the Allen telescope out there that has like about 40 dishes. And what they do is they actually listen for SETI, among other things. I think what Gunn was referring to is not the bandwidth, but the range of frequencies that you look at. Most of the search for SETI has been at the hydrogen line, because everyone figures, well, that's the common sort of denominator for life forms. I mean, as far as we know, life requires water, and so those frequencies around 1420 are also just sort of full. They're full of the hydroxyl Masters emission, 1667 and 1612, and so that whole range of frequencies has been sort of nicknamed the what was called the water hole. So it's a range of quite a number of a few dozen megahertz there band, and so the idea is that to maybe outside of the water hole to look at other frequencies. I mean, for example, I'm sure, I don't know if you guys are familiar, obviously, with the famous movie Contact. Of course, Carl Sagan wrote that, and if you actually, so the screenplay is a little bit different, but if you read the novel, I believe it's on the novel, is he had the idea, for example, of looking at a multiple of the hydrogen line. So the hydrogen line multiplied by a common sort of universal number like pi. So that'd be up there around 4 gigahertz something. So anyway, ideas like that. So the idea is just to not narrow look in that range of frequencies around the hydrogen line, the bandwidth there, but to spread out, look at other frequencies. And of course, it's kind of a guessing game. What's important to us might be totally irrelevant to an alien civilization, and vice versa. But I think that's what he was referring to. So yeah, Don's absolutely right. And actually, that's one of the problems. That's one of the problems with SETI. If you look at the communications nowadays that we're utilizing, we're shifting away from those narrowband frequencies and going to these digital wideband frequencies that are all spread out. And boy, if you don't have the right decoding software, it just looks like noise. It's just a blurb of noise in the RF background. And so obviously, any advanced civilization that's going to increase their communication bandwidth is probably going to go digital and these broad spread out frequencies. And so that's kind of a problem. If they're not just directly aiming a signal at us and we're just trying to sort of eavesdrop into some technical civilization, those signals aren't going to get very far. They're going to be much more difficult. I mean, we still have back in the 60s and 70s, we had the dew line radar systems. Those are relatively narrow bandwidth the pulses that would carry a long ways, and so we still have some of the airport radars and so forth that are narrow bandwidth. But the general communications have all drifted off from analog for relatively narrow bandwidths to these wide megahertz type bandwidth digital signals, and so that's a problem if another civilization's doing that in order to be able to detect those at a distance. But anyway, so much for that diatribe on SETI. I'm a big fan of SETI also, and I'd have to disagree with Wendy. I don't think they're going to suck our metals out. If they're advanced enough to get here, they don't need no metal from us. They've got all kinds of planets and things that they can and much more accessible to metals, and I don't think they're going to eat us either. Kind of silly.
No to serve man or no ionotropic iron, none of that stuff.
None of that stuff. I mean, just think of it. If you can travel light years to get here. That kind of technology, they're gonna go down to what, like eating gobbling humans? It's just not doesn't play out in logical any sense.
It'll first of all, it'll be robotics, and second, if I were going to transmit signals, I would always thought I'd put it at the ethyl alcohol lines.
Ethyl alcohol.
Yeah.
Gosh.
So they'll come and steal our bourbon.
I'm not sure that does it. I don't know that ethyl alcohol has lines.
Ethyl alcohol has some nice lines. Yeah, but they're a little higher in frequency than 1.4.
Of course, you have formaldehyde.
Okay, guys,
formaldehyde has it.
We're getting off topic here, so let's keep going.
Okay. All right. Well, that's all I had then.
All right. Thank you, Helen.
I'm just listening in, trying to learn all I can.
Okay, thank you.
Uh-huh.
All right, I've got all right, let me go to
might be everyone, Rich, I think.
Yeah, I've got something.
Yep.
And let's see. Can you guys see that? This is the Easy RA, Easy Radio Astronomy. And the lines across are the samples that I've done. So basically the drift scan samples. And one thing you'll note is that there's no bumps on them. And I'll show you why. If I process them individually, they have big bumps along where the thing is. But if I process them together, my problem is that I run into this. This is my RFI. So some of the samples have these big giant bursts here, and that causes the entire all of them, when they process them together, to be considered that's the range instead of the real range is right down here, and that'll allow you to see the big bumps and stuff. So that's part of my problem. But I'm doing a lot of sampling, and I have to go run through everything here. I have to go through each of these samples and drop all these things down, because those aren't real signals. Those are RFI signals. This is the dots are the highest signal strength at a particular point in the drift scan. And you can see anything along this line here are really good samples. You can see all the way across there. Anything that's not along that line is some kind of RFI in between. So these are all bad samples here. So then ones over here too. So you can see here, I got a lot of good sampled RFIs, but I need to get rid of all these here and then retake them. This is the one thing you can find if you can find the mass of the Milky Way, and this is right now I've got the Wikipedia value is 1.15 times 10 to the 12th. Sofu is a Japanese writer. He says 1 to 10 to the 11th. Mine's sort of this whole thing is sort of in the middle. It's 1.6 times 10 to the 11th. So I'm in the ballpark of the right sample, or of measuring the Milky Way mass. Last but not least, this is the picture I get of the spiral arms. Here's Earth, and here's this one spiral arm. You could probably see another one over here. And then you can see some of the outlier stuff here. That's the center of the galaxy in the green right there. Obviously, this will get better when I get rid of that RFI. It'll get more defined, and you'll probably see at least one more ring out here. So the software works really well in terms of getting that. And let me see if I can bring up the my screen here. There it is. I gotta drop everything because I want to show you the when I'm sampling right now. Let's see. And entire screen. That's all I've got. Paul, back to you.
I think we've been right around everyone. So there are some real progress being made. We'll give an update on the Heathcote dish once we get some information from Steve. Fingers crossed it's something minor that can be fixed. And we don't have another hiatus of a year or 18 months because we were doing so well. Thank you everyone for coming along. I was looking at the date for the next one, Rich. I think it's around about the 21st for you guys, Friday the 21st, Saturday the 22nd of November for us. And then we don't have one in December because it comes across Christmas and our summer holidays and so on. So we'll work on January after that. So I think we're there. Thank you.
Thanks,
All right.
everybody.
Thank you all.
Thank you all for coming.